Alright, let's talk about some base functions and just look at the pictures of them real quick. First of all, the three most basic polynomial functions are linear, quadratic, and cubic. In fact, there's one that comes even earlier than that. I'll put this down here. This is called a constant function. This is really a linear function, but it doesn't have any variables. So a linear function is going to look like a line. When you graph it, it's just going to be a straight line. That's what a linear function is. And the way you can tell by looking at the equation is it's going to have something, it's going to have an x to the first degree. It won't have a 1 on top, but that will be the highest degree that it has, and it won't have anything funky besides that. A quadratic equation looks like a parabola. The graph is a parabola, and the equation of it, you can tell it's quadratic because it has a squared somewhere, but nothing higher than a squared. That's how you can tell it's quadratic. So this gives away the fact that it's a quadratic, the degree of the polynomial. And you know that the degree is the highest variable. The degree of the highest variable is the degree of the polynomial. The cubic is the next one, and that's going to be something like x cubed plus something. And that graph is going to look like this. So these are your three basic, these are called polynomial graphs. These three are called polynomial functions. They're polynomial because they all are in this form right here. They all have something x to some power plus another something x to another power plus another something x to another power, etc. And the degree, the highest degree of the x tells you whether it's linear, quadratic, cubic, or you could go quartic, that would be a fourth degree, quintic would be a fifth degree, etc. A constant polynomial doesn't have any variables in it, it just has a number, like 3, which means it's constant, it never changes, and that's just a horizontal line like this. So this is actually technically also a polynomial equation. It's a line, but it doesn't have a slope. The slope is 0 when it's a constant, and you just have y equals a number. So those are 4 of your basic graphs, and you have to be able to identify those based upon either a picture or an equation, and so you have to be able to go from the picture to equation and vice versa. The other basic graphs that you'll need to know are absolute value graphs, and absolute value graphs are like 2 lines that meet at a point, or 2 rays, I should say, that meet at a point. That's an absolute value function. Some people think they look like quadratics. They have some things similar to quadratics, but actually they're derived from the linear equation. They're actually 2 half lines is what they are, but it bounces off at this point called a vertex right here. And the way you can tell that is that, very simply, it has an absolute value somewhere, absolute value sign somewhere, like something like that. You could also have +5 on the outside. That's an absolute value. And notice how that's the degree of that. Normally when you're in Algebra 1, the degree of that is still going to be 1 like a linear function. That's why it looks more like a line, and it is more similar to that. A square root function is related to a square. It's a quadratic. It's actually the square root function is a sideways, half of a sideways parabola. Look at this parabola up here. And if you turned it on its side and erased the bottom part, you have to erase the bottom part because it wouldn't be a function if you had the bottom part there. So that's the reason that you don't have that. And the way you can tell that is, of course, it just has like a square root of x somewhere. There's a square root of something in there. And again, this is going to be the square root, and there's only going to be an x to the single power. When you get into upper level algebra classes, you'll learn how to do a square root of a squared or a cubic function, and there's all kinds of different things you can do. An exponential function is the most different of all of these, and the way you can tell it's an exponential function is because the variable is in the exponent. So notice that these right here are not exponential because they're not variables in the exponent. This one has a variable in the exponent. And the dead giveaway for that is there's an asymptote. There's a horizontal asymptote, which means it approaches. As it goes to negative infinity, it approaches that, and then it goes through, usually it goes through the point 0, 1, unless you're adding or subtracting things on the outside, which you can do, and it goes off exponentially up. It gets very steep, even steeper than a cubic or a quadratic. cubics and quadratics were pretty steep, but this is like super steep. It's exponential, and it approaches an asymptote that it never touches. So it's important when you're seeing these things to know the domain and range. For a line, the domain and range are both from infinity to negative infinity generally, unless it's a constant function. Then the domain is all real numbers, but the range is only that one number right there, whatever it's going through. For a quadratic, the domain is all real numbers, so from negative infinity to positive infinity, but the range is defined by this point right here, which is called the vertex. Let's say that that's 1/2 right here. Then the range would be from negative 1/2, from negative 1/2 inclusive, so to positive infinity. And if it was an upside down parabola, it would be going from negative infinity up to that maximum point. Cubic is generally infinity, negative infinity, positive infinity, all real numbers for the domain and the range. An absolute value is similar to quadratic in terms of domain and range. Look at that vertex, and that vertex will tell you what the domain and range is. So let's turn this one upside down to give you another example. Let's say that's your parabola, and let's say that that point right there is 1. Then your domain is all real numbers, negative infinity to positive infinity, and your range is from negative infinity all the way up to positive 1 inclusive. Square root functions, notice that the domain and range are both going to be limited. The domain is limited. This one starts at 0 and goes to the right, so it's from 0 inclusive to positive infinity. And the range, that's the domain, the range is the same for this particular one because it starts here. I'm scanning it horizontally and going up. It's going to touch every y value bigger than and equal to 0 is going to have a point related on that graph. And then for an exponential, the domain is all real numbers typically, so negative infinity to positive infinity, and the range is from 0 not inclusive, so it doesn't touch 0, so it's an open bracket all the way up to positive infinity. So there's a really quick breakdown of all your basic functions and the domains and ranges of them.